Have you ever wondered why the dazzling white Taj Mahal has slowly turned yellowish in color? Turns out that air pollution is to blame for this discoloration. But what is it about the smoke from factories or vehicles that is causing this discoloration? Let's find out. The smoke from factories and vehicles contains the oxides of nonmetals. These oxides are formed when nonmetals are burnt in the presence of oxygen. When you burn carbon in the presence of oxygen, you get carbon dioxide. When you burn sulfur in the presence of oxygen, you get the oxides of sulfur. Let me just balance this second equation here. There you go. When you burn nitrogen in the presence of oxygen, you get the oxides of nitrogen. Now, I've written down a few nonmetallic oxides. Turns out all of these nonmetallic oxides are acidic. Not all the nonmetallic oxides in the world are acidic, but the ones I've written here, they are acidic. And these are the indirect cause for this discoloration. Let me explain how. Non-metallic oxides, which are acidic, when they react with water, you get acid. And that's what's happening here. All these non-metallic oxides react with water and they produce acids. CO2 reacts with H2O to give carbonic acid. Let me just write it down. H2CO3, carbonic acid. SO2 reacts with water to give sulfurous acid. And SO3 reacts with water to give sulfuric acid. NO2 reacts with water to give two acids, nitric acid and nitrous acid. Okay, so what's the deal with the discoloration of the Taj Mahal? When the smoke produced by factories and vehicles goes up into the atmosphere, it reacts with water vapor in the atmosphere to form an acid. And that acid forms clouds. And that, when it comes down as rain, is what we call as acid rain. This acid rain is the cause of corrosion of the Taj Mahal, and when the Taj Mahal gets corroded, it slowly gets discolored. Okay, so that's the entire process by which air pollution causes the discoloration of the Taj Mahal. Okay, now that we've gotten an idea about nonmetallic oxides, I want to discuss a little bit more about nonmetallic oxides and their chemical properties. Okay, let me bring you back to one familiar reaction that you know about, and that is the concept of acids and bases reacting to give salt and water, right? I'm sure you know about this. Now let me take an example. Let's say I take an acid H2CO3, carbonic acid, and a base NaOH, sodium hydroxide. Which salt do you think would be formed here? Yes, we would get Na2CO3, right? Great. Now, what if instead of an acid, we used a non-metallic oxide that's acidic, right? Would it react with a base? And if it would react with a base, what would the products be? Very interesting to know that the products would be salt and water in this case as well. Let's try with an example. So let's say we take CO2 and we get it to react with NaOH. We would get Na2CO3 plus H2O. Exactly the same products. The only difference would be when we balance it, it would look a little bit different, right? I balanced both the equations. Interesting, isn't it? So instead of the acid, we could use an acidic oxide to end up with the same salt. Okay, so in this video, we went through the entire process of how the Taj Mahal is losing its color. We also saw that, just like acids and bases give salt and water, metallic oxides, which are acidic, react with bases to give salt and water. That's it for this video. Thanks for watching.